Today's notes are on graphing and solving systems of linear inequalities. Your first step is going to be to graph the line that corresponds to each inequality. Remember that we draw a solid line for less than or equal to or greater than or equal to, and we draw a dashed line for less than or greater than. Then you're going to lightly shade the true regions for each inequality. You're going to shade above the line for greater than or equal to, and you're going to shade below the line for less than or equal to. You are going to find the overlap of all the shaded regions. This is your final solution region for the system of inequalities. So you're going to make sure that you shaded darker. If we go down and look at example number 1, the first thing I need to do is graph each inequality. So I need to start by solving them for y. The first one I can add 2x to both sides to get y is greater than or equal to 2x plus 1. The second one I'm going to subtract x from both sides to get 2y is less than negative x plus 8. Then I'm going to divide everything by 2 to get y is less than negative 1/2 x plus 4. And I need to graph each on my grid. So the first one that we found, I want to make a note that I'm going to have a solid line because I have greater than or equal to. And then because it says greater than, I'm going to be shading above the line. For our second one, I should have a dashed line because of the inequality symbol. And because it's less than, we will be shading below the line. So if I start at my y-intercept of positive 1, I have a slope of 2, so I'm going to go up 2 over 1, up 2 over 1, until I have some points on my graph. For you guys, you're going to want to make sure that you're graphing this with a straight line, so some kind of ruler or straight edge. So I'm going to draw a solid line. And then note that it was shaded above. Instead of shading the whole region, I'm just going to draw little arrows that indicate which direction I would be shading in. I'm doing this so instead of having 3 different shaded regions, both inequalities and then a final, this way I can kind of judge where the overlap's going to be by the arrows. So that's going to be my first inequality. The second inequality starts at a positive 4, and it has a slope of negative 1/2. So I go down 1, right 2, down 1, right 2, and I'm going to continue this pattern until I have a few points on my graph. And then I'm going to connect them with their dotted line. And because it was less than, we said we were going to shade below. So again, instead of having 3 shaded regions, I'm just going to draw arrows to start with. And now for the third step, I want to find where the regions would have overlapped with their shading. So I can kind of see using my arrows that this line has it pointed to the left. This line here has them pointed up. So this whole region in here is where the overlap of shading would have occurred. So I'm just going to color that in. This entire region makes up my solution. Please pause the video and try example 2 on your own. We will talk about the answer tomorrow in class. When you're done, flip it over, look at example number 3. We're going to do the same steps for example 3 as we did with example 1 and 2. The only difference is now that I have 3 inequalities instead of just 2, but we're going to treat them the same way. We're going to graph all 3 and then find where the overlap would have occurred. So I'm going to start here with y is less than or equal to 5. We want to remember that because it's just y, that this represents our horizontal line, so we're using the anagram HOI to help us. So I know that this will be a horizontal line based on the inequality. I also know that it's going to be a solid line, and I'm going to be shading below it. So I'm going to put that on our graph. Coming over at 5, here's my horizontal line. It's solid, and I'm going to draw arrows to indicate that I would be shading below the line. Then I'm going to look at the equation 6x minus 2y is greater than 0. We're going to start by subtracting 6x from both sides to get negative 2y is greater than negative 6x. Then I'm going to divide both sides by negative 2 in order to get y by itself. Remember that we flipped the inequality sign because we divided by a negative. So I get y is less than 3x. So if I'm looking to graph that, because I don't see a number added onto it, it has a y-intercept of 0. I then have a slope of 3, so I go up 3 over 1, up 3 over 1. Right, because of the inequality, I know that this will be a dashed line, and I will shade below. So here's my dashed line, and I'm going to just draw some arrows to indicate that I would have been shading the area here below the line. Our last equation, 3x minus 4y is less than 8. We're going to start by solving by subtracting 3x from both sides. I get negative 4y is less than negative 3x plus 8. I'm then going to divide everything by negative 4 to get y is greater than 3 over 4x minus 2. So again, I'm remembering that we had to flip the inequality. Based on the sign, we know that this is a dashed line, and because it's greater than, we will be shading above the line. So if I start at negative 2, I had a slope of 3 over 4, so I'm going up 3, right 4, up 3, right 4. I could do a couple in the other direction. And I'm going to connect these points with a dashed line. And it was greater than, so I would have shaded above. So because I have 3 lines, I want to find the region that has all 3 arrows pointed in at that, and that's going to be your region in here. So this center region here between all 3 lines is what makes up my solution. Please pause the video and try example 4 on your own. For tomorrow, we will talk about it in class.